Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Under traces of base, cyclohexanone undergoes an intramolecular aldol-type condensation or, more precisely, an isotopic label scrambling via enolization and intermolecular aldol reaction. The key here is the use of 14C labeled cyclohexanone where the carbonyl carbon is marked with C** 14C. Moving on to the next step. Cyclohexanone with a 14C labeled carbonyl carbon, C**, reacts under traces of base. Base deprotonates the alpha carbon to form an enolate. Moving on to the next step. The enolate of one molecule of cyclohexanone attacks the carbonyl, C**, of another molecule of cyclohexanone in an aldol addition. This gives a beta-hydroxy ketone intermediate. And for the final step, in the intramolecular or intermolecular aldol reaction of cyclohexanone under basic conditions, the classic product is 2,1-hydroxycyclohexyl, cyclohexane 1-1, but for this question the context involves isotopic labeling to track where C** ends up. When cyclohexanone, C** at carbonyl, undergoes base-catalyzed aldol reaction, the enolate alpha carbon attacks the C** carbonyl of another molecule. The resulting aldol product has a hydroxyl group at what was the C** carbon, now a secondary alcohol carbon, and a ketone at the enolate-derived carbonyl. This corresponds to option A1, 2-cyclohexanediene with C** on the appropriate carbonyl, which arises from the aldol condensation retroaldol equilibrium scrambling the label, effectively the self-aldol condensation product of cyclohexanone under basic conditions gives a diketone upon oxidation or rearrangement. Under base, cyclohexanone undergoes aldol condensation to give 2,1-hydroxycyclohexyl, cyclohexane 1-1, which upon retroaldol or dehydration and further reaction gives cyclohexane 1,2-dione. The 14C label at the original carbonyl carbon ends up at C** position in the 1,2-diketone product, option A. Why other options fail? B. 2-hydroxycyclohexane 1-1. This is the initial aldol addition product but does not fully account for the equilibrium under base with label scrambling to give the diketone. C. 1,2-cyclohexanediol. This would require reduction, not base-catalyzed aldol chemistry. D. 2-cyclohexane 1-1. This is the dehydration product, aldol condensation, but it loses the label information and is not the primary product indicated. The answer, A. Cyclohexane 1,2-dione with C** on one carbonyl carbon is the product of the base-catalyzed self-aldol reaction of 14C labeled cyclohexanone where the labeled carbon ends up in the 1,2-diketone framework. Therefore, the correct answer is A. Therefore, the correct answer is option A.